You are welcome back. This is the part D of this video course. I believe you have been gaining value ever since. And if you are watching this one, you have not watched the other ones, you are leaving my trouble, go back and watch the other ones. Well, so this in this video, we're going to talk about what excess and limiting reagents. Excess and limiting what? Reagents. That's what we'll talk about in this video. Then that's what we'll do first. Then as we move on, we'll now go to past questions as usual. Okay, now when we say excess and limiting reagent, like if you say something is excess, it means it's more than enough, right? If something is limiting, it means it's not sufficient. Now there are some chemical reactions whereby you have now let me write an equation. Now you see that this thing is kind of different from what you have observed ever since. For instance, H2 plus 2H2 plus O2 gives us 2 molecules of water. Now you know this equation normally, right? Now, what if you have a question like this? What is the mass of water formed when 5 grams of hydrogen reacts with 10 grams of oxygen? You see, now this one is kind of different because ever since the kind of questions we are solving, we have questions like what is the mass of water formed when 5 grams of hydrogen is reacted? Like it's just we have just one known amount. Like they give you the mass of one stuff, and you know the mass of another one. Yes. Now, but you see in this case, now they are giving us the mass of hydrogen. They are giving us the mass of oxygen. That's not for the mass of water. See that is kind of different. Now the reason why is if you see a question like this, that gives you more than enough parameters, or it's different from normal questions. On the normal day, if this question is to found that the ones we have been talking about, like it will not be mass relationship. And we have something like, what is the mass of water formed from reacting 5 grams of what? Hydrogen, or from reacting 10 grams of oxygen only. You will not have oxygen and hydrogen together, you get. So questions like this, it might not be in mass only. It might not be in mass only. You know we have talked about mole concepts. And then we have seen that number of moles goes to mass per molar mass. Volume at STP at 2.4 dm3 or 2 to 400 cm3, as the case may be. And it goes to CV over 1000 or CV. And it goes to number of molecules over Avogadro's constant. We have seen all those stuffs. Now, it can apply here. They can try to give you, let's say they will tell you that they will give you the concentration and volume of this guy, give you the concentration and volume of this guy, ask you for something about this guy. But the main thing is this: you have an extra parameter. You have they gave details. Now, I don't know if you get what I'm saying. Now, all the questions you have been solving ever since is usually one known and one unknown. Like they give you the mass of one thing or volume of one thing, something. But actually, it's not that they will give you two. Like it's all just gives us. They give us both the mass of hydrogen and oxygen. But that's us to do for the mass of water. So this is how questions or these are problems on excess and limiting reagents come. Do you get? They are just complicated like this. And guess what? They're actually easy. Now the main logic is this: if this is hydrogen and this is oxygen, and I have 10 grams of oxygen here, and I have 10 grams of hydrogen here, 10 each, right? Now, and then to produce water, I need 15 grams of oxygen. To produce a certain amount of water, I need 15 grams of oxygen. You agree with me that the amount of oxygen we have here is not enough, it's less than what we need to produce a certain amount of water. So we can see that oxygen is in limited quantity. Do you get? So it will not determine the amount of water that we're going to produce. Same thing, I said this is 10 grams of oxygen, this is 10 grams of hydrogen. Let's say we actually needed 5 grams of hydrogen, so we produce 20 grams of water, and they give us 10. It means only 5 out of that 10 will react. So it means hydrogen here is the excess reagent. Why? We have more than enough to react in the equation. Why for the limiting reagent, it is not enough. Do you get? That's different. So please take note that let me write this one here. Excess reagents do not partake in chemical reactions. Excess reagents do not partake in chemical reactions. Do you understand? So when they're giving you like let's say 10 grams of oxygen, 10 grams of hydrogen, they ask you to do for the mass of water. See, the question is which one are you going to use to determine the number of water? It is not the SS reagent, it is the limiting reagent that we use to solve. Do you get? It is the limiting reagent. Please take it. So your question is whenever you are giving questions like this that gave you information for two parameters or two different reagents, and it has to do for the product or the amount of one other reagent. Now, the one you have to pick is the one that is in limited quantity rather. Do you get? It's just like saying okay, let's say now, okay, let's say now we are playing a tournament, a football tournament, whatever, or a tennis tournament, whatever, basketball, baseball, anything. Now, look at it. Let's say I want Argentina out. You get? I want Argentina out of the tournament. You get? But Argentina has to play with both Mexico and Poland. And for Argentina to be out, Argentina has to lose both games. I don't know if you get the logic. Look at it. Now there's a football tournament, and I want Argentina to be kicked out. And the rule states that for Argentina to be kicked out, they have to play these two countries, and they have to lose to these two countries. So indirectly, like I say, the source of my evil plan to win Argentina is dependent on if Poland will win Argentina and if Mexico will win Argentina. Do you get? So that means my plan is that I don't want to see Argentina in this tournament. I don't like Messi. I mean, see Ronaldo fan again. I don't like Messi. That's why it's not good. But I don't want him in this World Cup. Get out. Now I have now said, okay, what will happen? Poland, I need to beat Argentina, and Mexico, I need to beat Argentina too. So it means my plan will fail if both of them don't beat Argentina. Do you get? So let's say, for example, Mexico plays with Argentina. Mexico beats Argentina 2-0. Poland plays with Argentina, and Argentina beats them. They lose. You get? Will my plan be successful? No. Why? Because they won one and lost one, and I needed them to lose two. So if I now say, who is the cause of this problem? Which country caused this problem that made my plan to fail? It is what? Poland. So if I have to punish anybody, what will I punish? Poland. That's the same logic I wanted to bring into this question. So they are giving you the mass of hydrogen, right, as 5 grams, right, 5 grams. And they are giving you the mass of oxygen as 5 grams also. They ask, okay, as 10 grams, sorry. Now they're asking us, what is the mass of water that will be formed? Now, the reagent that will lead to water formation, it is the one that is limited. As I say, SS reagent do not take part in chemical reaction. So please take note, the limitedness or excessiveness of a reagent is not a function of the mass, it is a function of the number of moles. Do you get? So do not say that oxygen is 10 grams here, and so hydrogen is 5 grams. That means oxygen is the SS. No, you have to use what? Number of moles. So if they are giving concentration and volume, you cannot still use that to know the SS or limiting reagents. You use what? The number of moles. Do you get? So look at this scenario: 5 grams of hydrogen, 10 grams of oxygen. Now that's not for the mass of water. And we know that we just need one of them to compare. You know what comparison we have been doing? Like 2 moles for this. You see that kind of comparison? Yeah, we'll still do it. But the first step we have to apply here is this: which of them are we going to use to compare with water? And that one we're going to pick is going to be what? The limiting reagents. The one that is a smaller what? Quantity. That's just the concept of limiting reagent. Once you have identified it, you leave the SS reagent and then use the limiting reagent to compare. Simple. Do you get? So let's go into this question. Then we'll solve like up to 3-4 questions, and then we'll solve them in different categories. And then you get to see how this thing works. Now stuff says what? What is the mass of water from? Now we have 5 grams of oxygen, hydrogen, and 10 grams of oxygen. You get? And we're looking for the one that we're going to pick that we're going to use to compare with water. Please take note, the degree of excessiveness or limitedness of what? A reagent is a function of the number of moles. So what we have to do is to convert these two things to number of moles. The one that is smallest is the limiting reagent, 𝗁𝗂𝗃, and then we work with the limiting reagent. It's easy. You get. Now, that's not this. Let's do more of the practicals, so we get to understand how this thing works. Now look at it. Remember, I said, how do we know which one is excess or limiting? It's not by the mass. It's not by volume. It's not by concentration. It's by what? The number of moles. So remember, in terms of mass, number of moles goes to what? Mass over molar mass. So we are going to do this for both of them. So let's see, this one is for oxygen, this one is for hydrogen. Mass over molar mass. What is the mass of oxygen here? Is it 10 grams? What is the molar mass of oxygen? 32. That will give us the value. What is the mass of hydrogen here? 5. What is the molar mass of hydrogen? 1. That's 5. So let me press 10 divided by 32 in my calculator. 10 divided by 32. That is 0.313 or 0.3125 moles. Originally, which one is smaller? Oxygen. But please, that's not the final stage. Now, when you have gotten these values now, use to divide the coefficients in the reaction. That is, in the reaction, oxygen is 1, right? You say divide by 1. In the reaction, hydrogen is 2, divide by 2. I don't know if you get the logic. So 5 divided is what? 2.5. This divided is 0.3125. So we check from this method, which of them is the limiting reagent? Oxygen. But you see that here now, this has a greater mass. So somebody that don't know how to solve this stuff now, the person will think this oxygen is the excess reagent. No, it is not a function of the mass, concentration of volume. It is a function of what? The number of moles. So look at how we did it. The first thing is to look at the number of moles of two of them that we are working with. You get? In this case, we will use mass over molar mass. Now, you can also use CV over 1000 for both of them. Now, it depends on the parameters we are given in the question. And I believe that if you have watched this to this point, you have seen us do a lot of stuff. So you have done a lot of stuff you get. So they should not be a problem to you at all. Because you should know which are the formulas to use at any given time. Because we have solved a lot of questions. And if you have been following, this is not an issue. You get. So let me recap. The first thing is to look at the number of moles of both of them. Now, this one is the mass over molar mass here because they give us masses. You get. So mass over molar mass of oxygen. You do it separately like this. If there is CV over 1000, whatever, do it separately. Now we have done this. The mass here was 10 grams of oxygen over 32. You already know that oxygen is 32 now, oxygen gas, right? Mass here is 5, molar mass is 1. Now when you get these values, you don't rest here. Even if the values you got, this one was actually smaller from the beginning, but we don't rest there. You get. What we now have to do is now, okay, now we have got this number of moles value. Now this thing is 2 moles of hydrogen, we actually 1 mole of, and we get this from the balanced chemical reaction. So when you have done this, you divide by the value here, then we get. So it means now oxygen is what? So this guy is what? Limiting reagent. And this guy is what? Excess reagent. Remember, this guy will not take place in the reaction. What we are concerned about is the limiting reagent. Please take note, the limiting reagent determines the extent to which a chemical reaction occurs. Please write it down. Write it down. The limiting reagents. So they can ask you a question from this information: which of these elements which of this element determines the reaction, the extent to which water production occurs? It is what? Oxygen, because it's what? The limiting reagent. So write it down as limiting reagent determine the extent to which what a chemical reaction what occurs. Do you get? So that's it. Let's move. Let's solve it out. This is not the question. We just did this first step to know which of them we have to work with. So now what we are comparing with is oxygen and what? Hydrogen. Remember from the reaction, 1 mole of oxygen reacted with what? 2 moles of water. Now what is now the moles of oxygen that was reacted to this reaction? We'll now go back to say N, because they give us mass. Mass of oxygen over what? Molar mass. That is what? 10 over 32. That is 0.3125. So you now say 0.3125 moles of oxygen reacted with S moles of what? Water as usual. S is what? 2 times 0.3125, which is what? 2 times 0.3125, 0.625 moles of what? H2. But that's only for the mass. Remember the number of moles goes to what? Mass over molar mass. And then mass is what? Number of moles times molar mass. What is the number of moles here? 0.625. What is the molar mass of water? Is 18. How do you know? H2O is empty as H2 plus O. H2 is 1 times 2, right? Plus 16. 1 times 2 is 2 plus 16, that's 18. So we multiply, so times 18. So the mass of hydrogen from water form is 11.25 grams. Do you understand? So let me break down this step. The first thing, look for the limiting reagents and then use it to compare, just like the way I've been solving before. Is this not easy? It is easy, very, very easy. Let's take example 2. Example 2. Example 2. Example 2. Okay, let's look for example 2. Example 2. Okay. Of what now? We are paired with sodium hydroxide. What is the mass? Oh, yeah, what is? Let me just use volume. Okay. What is the mass of sodium chloride formed? I believe I will not be writing all those sodium is 23, blah blah. You should already know them by now because one of the questions will give them to you. Now look at this. Look at this. Look at this. It says 20 cm cube of 0.1 mole per dm cube of HCl reacted with 15 cm cube of 0.05 mole per dm cube of sodium hydroxide, right? So what is the mass of sodium chloride that is formed? What is the mass of sodium chloride that is formed? What is the mass of sodium chloride that is formed? Simple question. Now look at it. It's now when many people see this, they want to do one foolish thing to go and use 𝗂𝗵𝗆 all over CB, V equals to NA over MB. See, I don't know what you're looking for here because you already have 𝗂𝗵𝗆, CB, and you know everything. So this is not going to work, never. So the knowledge that still plays here is still excess and limiting reagents. Now let's write the equation. We have HCl plus sodium hydroxide. Equals what? Please, sorry, I'm not writing the state of matter. I don't have the time. So everything here is balanced. You get. They asked us to look for what? The mass of sodium chloride that is formed. And you see, they gave us this volume and condition for this guy. They gave us CV for this guy. They also gave us CV for this guy. Just look for the mass of this guy. You see, this is where SS and limiting reagent. Now the question you want to ask yourself is that which of them is in SS and which of them is the limiting reagent from this equation? You get. So remember, I said the way we know is by the one that has the smallest number of moles. It's not by these values here. Just so we got this one, 20 is bigger than 15, and 0.5 is bigger than this guy. Then this one is the limiting reagent. No, it's not the right way. So remember, I said for both of them, let's say for HCl, we'll see what? CV over 1000. You already know this formula. For sodium hydroxide, we'll say what? CV over 1000. What is C here? 20, sorry, 0.1 times 20 over 1000. What about here? 0.05 times 15 over 1000. You get. So let me bring the values out. So 0.1 times 20 over 1000. 0.05 we have 0.0075. 2, 3, 4 moles. Now, is that or no? You divide it by the coefficients here. This is over 1 and this is over 1 too. So this is still 0.002 moles. This one is what? 0.0075 moles because divided by 1. If you add 2 here, we would have done by 2, you get. So between these two, now which one is actually the smallest? It is what? This guy. You see, so it means this is what? The limiting reagents, right? And this is what? The SS reagents. You get limiting reagent, SS reagent, 3 gram. So that is it. This is the limiting reagent, and this is what? The SS reagent. Limiting reagent, SS reagent, limiting reagent, SS reagent. That is how it is. Okay, now, since you are getting this now, it means since this guy is limiting reagent, is this guy going to be used to what? Compare to get what I'm looking for here. That's just the whole logic. So the reason why I'm doing all this stuff is to know which of them is the limiting reagent. That's the one we used to work to solve. So it is to now abandon what? HCl in this equation. So we say as usual, 1 mole of sodium hydroxide produce 1 mole of sodium chloride. And then that mole calculated just now was 0.0075. Because if you do it again, for sodium hydroxide is 𝗂𝗵𝗁. We have done it before. That's what this guy give us this value. And remember, it still give us 0.0075 moles of what? Sodium chloride. That's not for the mass. Remember that number of moles equals to what? Mass over molar mass. And that mass is equal to what? Number of moles times molar mass. Right? What is the number of moles here? 0.0075. What is the molar mass of sodium chloride? Sodium chloride is what? 23 plus 35.5. Right? You already know this value. 23 plus 35.5. That is 58.5. 58.5 times 0.0075. So we have that the mass is what? 0.44 gram approximately. You see, that is just how easy it is. That is how easy it is. You get. Let's solve 2 more. So the knowledge will be very solidified. So I won't go to Jambites questions or that past questions. It will not be hard. You understand? So that is it. Okay. So example 3. Example 3. What is the volume of CO2 formed from the reaction of 20 grams of CaCO3 and 25 cm3 or 0.1 mole per dm3 HCl. I'm not giving you H is equal to this, you already know those stuffs. So let's do solution, let's solve. Now the first thing is to bring out the equation. You already know these equations by now. HCl, 𝗁3 plus HCl is equal to what? CaCl2 plus H2O plus CO2. And I believe everything is balanced. You get. So you see, in CSS and limiting reagent, why? They gave us what? CV for this guy. They gave us mass for this guy. And they are looking for what? Volume of this guy. So it means from these two, we have to determine which of them is SS reagent and which of them is what? Limiting reagent first. Then we now solve to get the volume. You get. So the first one to say is this: NCaCO3 is equal to what? Mass over molar mass. So how is it mass over molar mass? Because the mass was given. This is the best way to get the number of moles. You get. Remember I said before, this is the third time I'm saying it, or the fourth time rather, that how you look for the SS and limiting reagent is not by the values that you are given, it's by the number of moles. Do you get? I don't know why all the equations we are just studying with. They don't used to have 2 here because of the balancing. So, but in case you have 2 here, when you look for the number of moles divided by 2, you get. So, this is mass of molar mass. What is the mass here? It's here 20. Molar mass of CaCO3 we should know by now that is 100. You get. What about for ACl? Because they are giving C and V, this one is CV over what? 1000. What is C? 0.1. What is V? 25. What is 1000? 1000. Okay, let's go to calculator. 20 divided by 100 is 0.2 moles. You get. Then let me change this thing to 250. Let me use 250. 250 cm cube. So here will have 250, right? So 0.1 times 250 divided by 1000. So we have 0.025 moles. Divided by, we have coefficient here is 1. The other one is 1 here. Divided by 1, divided by 1. So if we add 3 here, you see divided by 3. The value here, that's what you need to compare the value we have here. So don't get into this 1 and think it's a rule. You get. So we have 0.2 moles here. We have what? 0.025 moles. So which one is this one is what? Limiting reagent. This one is what? SS. Which one will concern this guy? We're not concerned with this guy. So please take note of this value too, because we'll still use it. This very value. See, one of the mistakes you can make that I used to make that time is this. Now remember, this is the original value we got from this. If this place was 2 now, we will say divide by 2. See, don't go and start using this value that you divide by 2 as the new number of moles to compare. You fail fully. You get. If I know that I'll be doing this again, I'll be making this. So I think that we establish that confusion in you. You get. Okay, see. Now. Okay. Now, so what is our limiting reagent just now? It says Cl now. So 1 mole of ACl produces what? 1 mole of CO2. Yeah, so we now use this value to look for the current mole of this guy. So N is what? CV over 1000. C is what? 0.1 times 250 over 1000. That was what? 0.025 moles. Okay, so 0.025 moles of what? ACl will give me X. Obviously, if you see give me that, it is what? 0.025 moles of CO2. But we're looking for the volume, right? Remember that number of moles equals to what? The volume that we're looking for was 2.4. So the volume we're looking for is what? Number of moles times what? 2.4 dm cube. What is number of moles here? 0.025 times 2.4. 0.025 times 2.4. So we have that the volume is equal to what? 0.56 dm cube. Now you can use 2 to 400 here to give you cm cube value. What will determine that is the unit of the volume we have in the options. So I think what have we not even done here, safe? Okay. Let's take example 4. See, I'm just trying to relate it to different parts. Yes. So the concept is the same. Which that varies. See, we are using which number of mole formula are we using? That's the reason that varies here. You get, so that's it. Okay. So example 4. Example 4. Okay. What is the number of molecules formed? Molecules of SO3 formed from the reaction of 20 dm cube of SO2 with 20 dm cube of O2. You get? So this one, I think this one is another dimension. You get? So the logic is still the same. The first thing is to write the equation. SO2 plus O2 plus SO3. Is it balanced? No. I need that 2 will be here. Let's see first. And 2 will be here. So we have 2 sulfur, 2 sulfur, 6 oxygen, 4 here plus 2 is balanced. So and they say this guy is 20 dm3, and they say this guy is 20 dm3. I'll look for what? The number of molecules here. So the first thing to look for which one is SS for limiting. Remember, for SO2 is what? The volume over 22.4 dm3. That's how I look for the number of moles. Same thing for what? Oxygen. So it's still volume all over what? 22.4. What is the volume that we're given? 20 over 22.4. Okay, that will give us. Now I love this question so much because we're having the same values, right? We are having the same values. Very, very good question. Now we have 20 divided by 2.4. So we have 0.893. 0.893 moles. And that's the thing we have here. 0.893 what? Moles. Someone will now say, but sir, we have the same value. Which is not the SS. Do you know we're not done? Yes, we use the values. You see what is standing here. So you divide this one by what? This one is just 2. Divide by 2, right? This one divided by 1. That's what will bring the difference. So 0.893 divided by 2 here. We have 0.4465 moles. That's the big one now. 0.893. So which one is this? Was the limiting reagent, and this one is what? The SS reagent. She grab now. So she see this stuff. So now what I want to do now is this guy and what you're looking for. Very, very easy. You get. Now you see, there's one mistake that you're unlikely to make now, but I'll prevent you from making that mistake. Now we'll not start comparing that. 2 moles of this guy produces what? 2 moles of this guy. So what is the number of moles that was produced here? What is the limiting? You get. It is what? N equals to what? The volume over what? 2.4. That's 20 divided by what? 2.4. Now we have 0.893. Now some persons will want to use that value of when we have divided it by 2. No, that's we only needed that stuff to look for which one is SS and limiting. You don't use that value. You get. So this is what? 0.893. This is what? X. S will definitely be 0.893 moles of what? SO3. Because this, I think that when they have the same here, whatever here, that will still be the same, right? Now we are looking for number of molecules. Remember that number of moles is equals to what? Number of molecules or particles, whatever, all over 6.02 times 10 to the power 3. That's Avogadro's constant. So it means number of molecules now equals multiply. Number of molecules is equals to what? Number of moles times 6.02 times 10 to the power 3. What is N? 0.893 times 6.02 times 10 to the power 3. You get. So that's 0.8993 times 6.02 exponential 23. So the number of molecules of this guy is what? 5.4 times 10 to the power 23 approximately. You see, that's it. So guys, we have solved 4 questions, and I did go to make sure they touch all the number of moles formula. See, that's just the logic is just look for the SS or limiting reagent using number of moles divided by the coefficient here. That's it. So let's go straight up into past questions. Let's see how the past questions look like. Are they harder than what I've thought? Are they easier than what I've thought? Let's get to know now. Hope you got this value from this video. Please just continue. Let's continue. Let's go into past questions. Alright, so let's go to past questions. Yep. Past questions. Okay, I have about 5 of them. I'm just going to rush because there's no time. Let me just rush it and then we are done. So the first question I want to take is this. Let me drop this marker. The question says, how many grams of hydrogen gas, will be liberated when 6 grams of magnesium ribbon dissolves in 500 cm3 A says 1.2 gram, B says 0.7 gram, C says 0.5 gram. Option D, I did not snap that part. I just look option D is not the answer. Alright, so let's solve. So it's just as easy as everything I've been doing ever since. Now they give us all those hydrogen equals to 1, but I'm not giving it to you. You should know it by now. Now let's write the equation. So when 6 gram magnesium dissolve, the reaction is that HCl reacts with what? Magnesium, or magnesium is a displacement reaction because magnesium chloride plus what? Hydrogen gas. This we have 2H here, everything is balanced. And they gave us what? 6 gram of this guy. And they gave us what? CV of this guy. So what we are going to do is that let's compare, let's look for the one that has this smaller, which of them is the limiting reagents you get? Is mass over molar mass here. Why they give us the mass? 6, magnesium is 24. You get, it gives a value. For HCl, it is what? CV over 1000. What is C? 6. What is 500 over 1000? It gives a value. Let me just calculate up. Now 6 divided by 24 is 0.25. 0.25 moles. 6 times 500 divided by 1000 is what? Theory. But remember that this HCl is over 2 because you have 2 here, so you have 1.5, here we have 0.25. So it shows that magnesium is what? The limiting reagent. So we use magnesium to compare, right? That's it. So you are seeing the board, okay? So it means 1 mole of magnesium produce 1 mole of HCl. Then let's look for the number of moles again. Mass over molar mass. What is mass? 6 to 104. That's 0.25. You get. So 0.25 moles of magnesium produce S of hydrogen. If you will still have what? 0.25 what? Moles of what? Hydrogen gas. So I'm looking for what? The mass. How many grams? Number of moles is equals to what? Mass over molar mass. So you know. And then we also know that mass is equals to what? Number of moles times molar mass of hydrogen. What is the number of moles? 0.25. What is the molar mass of hydrogen? We're talking about hydrogen gas here, right? That would be 2. You get. That's 0.25 times 2. That's 0.5 gram. That's 0.5 gram. So option C is correct. Check see how it works. So that is just it. So let's go fast into what? That's a jump pass question, by the way. I forgot to state the year. It's a jump pass question. You get. So let's move. Okay. Okay, I already snapped it. Let me get the next question. This is the next question. All my markers are already faint. Okay, the next question says what is the amount, back in says in gram as in G, of water produced when 5 grams of hydrogen, 5 grams of hydrogen and 5 grams of oxygen react together. And that's it. The equation of the reaction is, now write it here, 2H2 plus O2 is also H2O liquid. You get. So you ask me what is the mass of what? Water. So you see they said 5 grams of hydrogen and 5 grams of oxygen. You get. So the main you want to talk about, because they give us 5 grams here, 5 grams here. So I want to look for the excess and the limiting. We'll work with the limiting. So let's say this for hydrogen. mass over molar mass. What is the mass? 5. What is this thing? Hydrogen is 1. You get. For oxygen, mass over molar mass, which is equal to what? 5 over 32. You get. This is 5. 5 over 32 is what? 5 divided by 32. 0.156. You get. But this thing, hydrogen here is 2. Divide this one by 2. That's 2.5. So that's 1 divided by 1. 0.156. So it means oxygen is what? The limiting reagent. You get. Oxygen is the limiting reagent. Right? So we're going to compare. So it means 1 mole of oxygen produces 2 mole of water. You get. Then now you get the number of oxygen again. From this one, I say 5 over 32. I believe it was 0.156, right? So now that 0.156 reduce x. So x equals to what? 2 times 0.156, which equals to what? 2 times 0.156, which is equals to what? 0.312 moles of water, which is H2O. Right? Remember that number of moles equals to what? Mass over molar mass. So it means mass is equals to what? Number of moles times molar mass. Number of moles here is what? 0.312. What the molar mass of water is, you can calculate it. So that's 5.616 gram of what? H2O. So you see, that is just how it is. Example 2 done, 3 more to go. Yes. So all these things are very, very easy. We have done all these models before. There's one complicated one. That will be the last one. We're going to solve it too. You see. Now please, your knowledge about equations will really help you in this topic. That's just the plain truth. That's the plain truth. Okay. Let's go to example number 3. See, calculate the number of molecules of carbon 4 oxide produced when 10 grams of CaCO3 is treated with 100 cm³ of 0.2 mole per dm³ HCl. The equation of the reaction is CaCO3 plus 2HCl gives CaCl2 plus H2O plus CO2. Get. So let's get the equation where this is look at the number of molecules of CO2, right? Produce when what? 10 grams of this guy is treated what? Again the CV of this guy. So as usual, I want to look for the what? The limiting reagent first. So NaCO3 is equals to what? Mass over molar mass. While NaCl is what? CV over 1000. What is the mass? 10. What is the molar mass? 100. You already know that one. This is going to give us 1.1. You get. What is C? C is what? 0.2 times what? 100 over 1000. So 0.2 times 100 over 1000. We have 0.02 divided by 2. We have 0.01. So this one is 0.1. So this one is smaller. You get 0.1 is smaller than 0.01. So HCl is what? The limiting reagent. So that's what we work with. So we have done step 1. Then we write the code. So remember we are comparing HCl with our oxide. So 2 moles of HCl here produces what? 1 mole of what? CO2. Then with this value, let's put the number of moles of HCl. That's CV over 1000. That is what? 100 times 0.2 divided by 1000. And we'll go to 100 times 0.2 divided by 1000. So we go 0.02. Please take note. You know why I have to solve this a bit? Somebody will say to you, I've done it before, I didn't do it again. You see, that time we did it to look for the limiting reagent. We have to divide this value by these two. But that's not what we need here. That's not the real number of moles today. So it means 0.02 moles of this guy produce X. So X 2X is equals to what? 0.02. It means X equals to what? 0.02 over 2, which is what? 0.01 moles of what? CO2. Remember, I look for the number of molecules. I remember that N equals to what? Number of what? Molecules over Avogadro's number, which is number of molecules, right? All over 6.02 times 10 power 23. So number of molecules equals to what? N number of moles times 6.02 times 10 power 23. What is N? 0.02, right? Times 0.02 times 6.02 exponential 23. I made a mistake. Let me see this thing again. 100 and 0.2 and 1000. So please take this note. This number of moles here is what? 0.01, right? Times 6.02 times 10 power 23. That is what? 0.01 times 6.02 exponential 23. That is 6.02 times 10 power 21. That's the number of moles of what? Number of molecules of what? 𝗁𝗂𝗆 that is produced. So that is number 4. See, everything is following the same concept. It's just very, very, very easy. When you don't know it, that's why you feel it is an limiting reagent. It's actually hard. That's not true. Okay? Let's say example 4. Example 4. Example 4. Example 4 is similar to example 2. Now I have to do with magnesium and HCl. The only thing that I change the parameters. So no need to solve that stuff again. No need to stop it again. You no need to solve it again. Alright, so let's take the last one. So it's kind of complicated. But it's really complicated. People don't understand the concept. So I know you are not one of them. So let's go. Let's go. Alright, so because it says 100 cm3 each of 0.2 mole per dm3 solution of hydrochloric acid and lead to try also nitrate 5 were mixed, right? Okay, assuming that lead to chloride is completely insoluble, the mass of lead to chloride precipitated is, let me just go up, so let me give you these things. That lead is 207, chlorine is 35.5, oxygen is 16, N is 14, H is 1. Look at the options. Option A, 9.92 gram. B, 8.54 gram. C, 5.56 gram. D, 2.78 gram. This is the last one. You see how long it is. But it's still easy. Now the first this side I told you that you have to know equations. The first you have to know is that this reaction is the same thing as what? They said HCl and lead nitrate. Let me write it the way it came. This lead nitrate. Is just what? 𝗶𝗶HCl2 and what? HNO3. How do I know? It's normal precipitation reaction. I know that this guy will react, this to come like this, to take this guy. You get a volatile acid solid from precipitation, you get. So the first one to check now if the reaction is balanced. If it's not balanced at all. First if I put 2 here, how will I know that I'll put 2 here? I already know that this NO3 is 2 here. So I have to do it to balance that part. Hydrogen here is 1, let me put 2 here. So it means hydrogen is balanced, chlorine is 2. See, it's balanced. Lead 1, chlorine 2, chlorine 2, hydrogen 2, hydrogen 2, NO3, N2, oxygen 6, N2, oxygen 6, balanced. So now they gave us what? CV here. That's because this V and this C, they said each. So it means it is 100 cm3 of 0.2 mole per cm3 of this guy, and also 100 cm3 of 0.2 mole per cm3 of this guy that we added. That's what they mean by that each. We are looking for what the mass of this guy is from. So again, within this we are looking for ocean is what ACL summation is limiting. You get. So let's say for ACL is equals to what CV over 1000, right? For PbNO3 to lead nitrate, is still what CV over 1000. You get what is CV? 100 times 0.2 divided by 1000. You get it is empty as what 100 times 0.2 divided by 1000. So 100 times 0.2 divided by 1000. So we have 0.02 for both of them. So 0.02, 0.02. Remember you divide by the coefficients here. So ACL divided by 2, this guy divided by 1, right? So we now have 0.01 here, we have 0.02. So it shows that ACL is what? The limiting reagent, while this guy is what? SS. So step 1 has been done. We have located that ACL is what? The limiting reagent. Now, ACO, very easy. Now, we now compare with ACL. So we say 2 moles of ACL with this 1 mole of this guy. You get. Then with this value for the number of moles of ACL again, CV over 1000. What is C? 0.2 times 100 over 1000. So NaCl is already what? 0.02. So we now say 0.02, which is X mole of this guy. So 2x equals to what? 0.02. X equals to what? 0.02 divided by 2. This is 0.01 mole of what? PbCl2. Remember we are looking for what? The mass. Let me do that part here. We are looking for the mass of that guy. You get. And remember the number of moles equals to what? Mass over molar mass. And that mass is number of moles times molar mass. Where do you know the molar? Where do you know the number of moles? So mass is 0.01. What is the molar mass of what? PbCl2. Simply as Pb plus Cl2. Pb is 207 plus 35.5 times 2. So 207 plus 71. You get 207 plus 71. 278. So you have 278. So this is what? Times 278. So the mass is now what? 2.78 grams. And that makes the correct. So guys, Jesus. I just went back to play the video and I saw that reaction. I was like, Jesus. You know, it's very, very, very tough and very, very painful when you have recorded the video and the video ended. Thank God it did not end. My battery was low. So guys, that's it. So we are done with this 𝗁𝗏𝗏 course. Man, that's not been an easy journey. Right from the first video to the second video to the third video. See, this stuff took me weeks to record. Weeks. Coupled with school. Coupled with other things I'm doing. So I had to make this video available for you. So what I want to do is to make the best out of this. See, I've taught you 𝗁𝗏𝗏. All you have to do is to go and get yourself used to questions. Go solve questions, solve. So just keep solving. You understand? So please tell your friends about this video course. This video course is paid. You get, and if you are getting it for free, me are among the first set people that are helping to test the video. But if you got it for paid, just tell your friends about it and see. There's this video course on 𝗁𝗏𝗏𝗏 that have. See, don't be a bad friend. There's somebody that is dying out there. See, this stuff will not touch your secondary school like this. Your teachers could not teach it like this. The way I taught it. See, the reason I can teach this is because I've had a lot of experience, years of experience in academics to get, and I've been able to simplify stuff like this. It's not as easy as you think. So please do well, recommend this video to your friends. Thanks for watching. God bless you. By God's grace, I'm Dr. Igi. I'm the CEO of Explicit Online Trials. You should join us for our classes. We will not lead you astray. We will lead you to that powerful result you want to get. So thank you very much for tuning in. I'm Dr. Igi. You are blessed. Bye.